Let's learn about the PN junction diode. It is the foundation of semiconductor devices. It controls the flow of current. Let's explore its fascinating working principle.
Meet the P-type and N-type semiconductors. When joined, a fascinating process begins. Electrons and holes diffuse across the junction, forming what is called the depletion region. Inside a diode, a depletion region forms. Electrons and holes diffuse across the junction. They recombine, leaving behind charged ions. This creates an internal electric field. It halts further flow, forming a barrier.
To forward bias a diode, the depletion region shrinks, allowing electrons to flow freely.
Under forward bias, a smooth flow begins. Electrons rush from the negative N region, while holes move oppositely toward the N region. Their meeting creates a continuous electric current. In reverse bias, we connect the positive terminal to the N side. Mobile charge carriers are pulled away from the junction. This causes the depletion region to widen, and current flow stops completely. Understanding diode current direction. In forward bias, current flows from anode to cathode. Reverse bias blocks the flow completely. It acts as a one-way street. Watch how a diode rectifies AC. It only allows the positive half to pass through. This converts it into pulsating DC. Let's verify the result on our oscilloscope. This is an AC sine wave. It moves back and forth. Let's pass it through a diode. The diode blocks the negative half, leaving only pulsating DC. That's rectification. Inside a PN junction, silicon forms a precise crystal lattice. Forward bias pushes electrons and holes toward the center. They recombine, releasing energy. This flow creates continuous electrical current.
Learn how a diode works. Forward bias allows current to flow. Reverse bias blocks it completely. It converts AC to DC. It is a one-way street for current.
Meet the diode, the gateway of electronics. It allows current to flow in just one direction. This simple principle powers our entire digital world.
A diode is a one-way street for current. Different types serve special purposes in circuits, like LEDs, which emit light when current flows. From rectification to voltage regulation, meet the rectifier diode. It allows current to flow in only one direction. It turns messy alternating current into smooth, direct current, essential for all your chargers. Meet the Zener diode. It allows current to flow in reverse. Perfect for voltage regulation and protection. Used in power supplies and all smart devices. Reliable and incredibly efficient. Meet the LED. It glows when electricity through semiconductors. They come in many colors and are super efficient. That's why they're used in TVs, light bulbs, and even your smartphone screens. They're lighting up our world. A diode is a one-way street for current. Different types serve special purposes in circuits, like LEDs, which emit light when current flows. From rectification to voltage regulation, meet the rectifier diode. It allows current to flow in only one direction. It turns messy alternating current into smooth, direct current, essential for all your chargers. Meet the Zener diode. It allows current to flow in reverse. Perfect for voltage regulation and protection. Used in power supplies and all smart devices. Reliable and incredibly efficient. Meet the LED. It glows when electricity through semiconductors. They come in many colors and are super efficient. That's why they're used in TVs, light bulbs, and even your smartphone screens. They're lighting up our world. Light in, current out. It works in reverse bias using the photoelectric effect, generating a precise current. They are super fast and highly sensitive, used in medical tech, comms, and
What is a Schottky diode? It joins metal to a semiconductor, giving it low voltage drop and fast switching. It's super efficient but has lower voltage ratings, used in power supplies, solar panels, and RF circuits.
Let's compare 5 types of diodes quickly. Rectifiers convert AC, Zeners handle breakdown, while photodiodes detect it. And Schottky diodes are super fast. Check this table for all details. Diodes are everywhere in modern tech. Rectifiers turn AC to DC, while Zener diodes regulate voltage. LEDs give us light, and photodiodes sense it super fast. They power our entire digital world.
Which diode is best? Let's compare. Schottky has low voltage drop and switches super fast. LEDs are super efficient but need a resistor. Zener diodes are best for voltage regulation. Subscribe for more quick tech breakdowns.
Allow one-way electron flow. Zener diodes handle reverse breakdown. LEDs emit light from flowing energy. Photodiodes detect light to make current. And Schottky diodes switch at ultra-high speeds. Diodes are everywhere. They turn AC to DC in your chargers and laptops. They light up bulbs and send remote signals. They power solar panels and streetlights. Diodes make modern life possible. Let's master the types of diodes. AC to DC. Zener diodes regulate voltage. LEDs give us bright light. Photodiodes detect light. And Schottky are ultra fast. Now you know them all. Keep learning.